In this video, we want to introduce also another type of subset, which we refer as a proper subset. So we look at the definition. Supposing we have two sets, in this case now we're having P and Q. So we're using P and Q. That tells you that we can use any symbol of our choice. In the previous video, we are using A and B. Here we choose to use P and Q. So we can use any capital letter to represent the set. Now we have that P is a subset of Q, but P is not equals to Q. So when we have a situation like this, that P is a subset of Q, so we have two sets, which one is a subset of the other, and the two of that sets are not equal, then we say that P, which is contained in Q now, is a proper subset of Q. So we have that P is a proper subset of Q. And how do we write it symbolically? We write it as follows, that P is a proper subset of Q. So you'll observe in this notation, we are missing the bar. So the bar is not here. So when we have the bar, it means subset. That tells you there is possibility that P can be equals to Q when we are talking about subset itself. But in this case, we are now talking about proper subsets, where there is no possibility that this set P can be equals to Q. So in that case, P is now a proper subset of Q. So we use an example to illustrate this, or to show a clearer picture of this definition. So we have a set Q. Q are made of the elements A, B, C, D, and E. And we have another set we call P. P contains the elements B, C, and D. So first thing to observe is that, let me write it clearly. So we have Q, you have A, you have B, you have C, you have D, you have E. Okay, and the next set we have is P. So we have P to be B, C, D. So the first thing to observe, the observation to make is as follows, that one, every element in B is in Q. So we have B now. So this B is an element in P, and that B is also in Q. Again, C is an element in P, that element is also in Q. Then finally, the element D is in P, and the same element is in P. Now, what do we observe? We observe that every element in P is in Q. So write that P is a subset. So write that P is a subset of Q. But one more thing, there's an interesting thing there. An additional information is also giving us about these two sets. What is the additional information? The additional information is that the set P, this set P, is not equals to set Q. So we have an additional information that P, the set P, is not equals to. So we also use this negation to show not equal. So we have that P is not equals to Q. So that is an additional information given to us. Now, with this additional information, we can write this in properly now. How do we write it now? Instead of writing that P is now a subset of Q, we now write it based on the additional information given to us. So what we now write is that P is now a proper subset of Q. And we write in that form. Therefore, this one, we now clean this one. Okay, so what do we have now? This one now becomes a better form of writing this subset. We now say that P is a proper subset of Q, because we are given that P is in Q and that P is not equals to Q. So with that way, we can write that P is a subset of Q. In this example, we want to see how to make a proper use of subsets and notation. So for instance, we have a set W. W is written in a set builder form. So we have W. The members of that set are weekdays. Okay. Then we have another set D. The members of this set D are Monday, Tuesday, Wednesday, and Thursday. Now we want to look at the relationship in terms of W and D. So we want to see how we can appropriate these symbols, subset and proper subset. So what do we observe? The set W are made up of the weekdays. And what do we refer as the weekdays? The weekdays are like the working days from Monday to Friday. So this one will contain Monday. So supposing we write it in a short form, this becomes Monday, and this becomes Tuesday, this becomes Wednesday, this becomes Thursday. We're talking about the weekdays. And finally, we have Friday. So this should be the element of this set W. And of course, the element of set D is already given to us. The elements are made up of Monday to Thursday. So right, we have Monday, we have Tuesday, we have Wednesday, and finally we have Thursday. So these are what we have there. Okay, now which symbol do we use now? First of all, we observe one thing. We start with this observation. First, what do we observe? That every element in D is in W. That is, here we have Monday. Monday is in D. Monday is also in W. Tuesday is in D. Tuesday is also in W. Then Wednesday is in set D. Wednesday is also in set W. Thursday is in set D. That Thursday is also in set W. So what do we observe? We observe that the set D is also in set W. But one more thing is there. How many elements do we have here now? Here in this case, we have how many elements in D? We count. We have 1, 2, 3, 4. So there are 4 elements in D. And here again in W, let's count the number of elements we have. We have 1, 2, 3, 4, and 5. So what do we observe? The set W is not equal to set D. But the element in set D is in set W. So the notion we're going to use here is what? A proper subset. So here we now say that D, so we now write that D is a proper set of the set W. Reason being that every element in D is in W. So we have every element here is also in W. That's number 1. Then number 2, we observe the set D. This set D is not equal to set W. So with these 2 conditions given to us, the proper symbol to use is a proper subset. So write that D is a proper set of W. And that's what we have in this case.